Today, let's go through the LeetCode 314 binary tree vertical order traversal. It gives the tree, and let's return the vertical traversal result. And let's take a example. Let's say this tree has a root 3, and has a left child 9, right child to be 20. And it need to have the result from the, let's say, from here, and here, and then here, and here. So for the question is trying to get a list of integer of the node. And also the question has said that if two nodes are in the same row and column, the order should be from the left to right. That is, let's look at the second example. That is because 0 and 1, they actually, as we consider this one, for example, this one column index, I say this is 0, this is -1, this will be -2. And on the right, it will be 0. And this will be +1. And on the left, it will also be 0. So this 0 and 1, they have the same column index. This will be 2. But if we put that into an list, 0 should prior to 1, because it should show from left to right. And also we see the 3 will be the first one. So the intuitive way for us is that we use a map. And the map, the key will be the column index. And the value will be list of integers. And for as a result, return some kind of the values. For example, this is from the first traversal is from the left to right. So we need to have the keys to be some kind of order. So I'm thinking using a tree map. Of course, we can use a map and then sort the keys. And then the key will be the column index. And then we just do a traversal, no matter it is BFS or DFS, we put the values into the corresponding list, and then return this kind of value converted to the result. So let's write the code. We need to firstly try to see if root equals null, what we are going to return a new array list. As probably mentioned, we use a tree map to store the column index. The value will be the list of integers. I'm going to create two queues. Of course, there are two kind of approach. One is because for each node, if we put that for BFS, we are going to put those kind of tree nodes into the queue. One of the approaches we create a node class to encapsulate the tree node in the index. I don't know, we have maybe it will have a tree node and also have a column index because we need to store the column index somewhere. And this will be one approach. Another approach is that I just do not create a actual class. I just use one queue, two queues to handle the situation. Still use a tree node. We call TQ because new tree array. There. And another queue, I will just store the column index. I call index queue or IQ. And we put the root into those queues. And also we know for the root, it has a column index to be 0. So we just write a BFS because it's very easy if we to write a BFS while TQ and we have tree node equals TQ dot pull. Also we have the column index equals IQ dot pull. When we pull this node out, we just need to put that into a map. The thing is that it may, those kind of list, the list may not exist. So we can use a function called compute if absent. And the column will be the key. K equals new array list. And add this node dot value. Now is that we need to trying to find if it has a left child, if node dot left unequal to null, then we put that into queue. TQ, that is node queue offer node dot left. And also we need to have the column index queue, IQ offer column that is -1. The same thing on the right, node dot right unequal to null. Just TQ offer node dot right and IQ offer dot column +1. So what we return, because it's a tree map, we just its values we convert it to a list. So we just return new array list map of values. So let's try to new array list integer. Should be some list integer. Anything any other errors? Q new array deck type arrow for line 30. And let's try and see. Yeah, let's submit. Okay. Um, we use BFS. The good thing is that it will always show the order, for example, 301, so that we not need to compare whether zero is because BFS is iterated from the left to right. We don't need to compare whether it is from the left tree or right tree. Let's consider the time complexity and space complexity. We iterate the whole tree, assume there are n nodes, so the time complexity will be O(n). For the space complexity, we use Q, DFS, we use BFS, we use Q, so it is also O(n). Okay.